Hello everyone, my name is N. Sivakumar, Department of Chemistry, Kamaraj College of Engineering and Technology. I am going to discuss about the topic analysis of coal. So in the analysis of coal, we have discussed about the ultimate analysis. The ultimate analysis in the previous video lecture, I have discussed about the ultimate analysis of about carbon and hydrogen. Next one is nitrogen content by Geldof method, carbon and hydrogen by combustion apparatus. So here in this video lecture we have to discuss about the sulfur content. So how the sulfur it can be analyzed by the this kind of ultimate analysis. So a known sample amount of the coal sample, it is burnt completely in a bomb calorimeter. So for the sulfur content analysis, bomb calorimeter is needed. So that here during the process sulfur is converted into sulfate. All the form of sulfur present in the coal, it is formed as a sulfate, so which is extracted by the water, and the extracted is treated with the barium chloride. So that barium chloride solutions, so all the chloride are converted into sulfates, so that sulfates are precipitated as the barium sulfate. Barium chloride that will be converted into the barium sulfate. The precipitate are filtered, dried and weighed. So from that, what is the amount of barium sulfate that can be calculated, and from that we have to calculate the amount of sulfur. So because you may know that barium sulfate, it also consists the sulfur. So what is the weight of sulfur present in the barium sulfate, it can be easily represented. So only we have chosen this kind of way. So from the weight of barium sulfate obtained, the sulfur present in the coal is calculated. So it is like this. So this is the bomb calorimeter. So let us see the construction of the bomb calorimeter. So in that this is the insulated outer container, it is made up of wooden box. So inside there is a steel bomb. This content or container, it is called the steel bomb, it is represented. So here this is the oxygen for the combustion process. So this is the inlet of the oxygen for the burning process. So here the ignition wires are being employed for the burning process. So this is called the ignition coil. So these are the ignition wires and this is the ignition coil. So the whole steel bomb are immersed into the water container. So in this container it is fully covered with the water. So then in that stirrer is employed for the uniform temperature. The stirrer is being employed and the thermometer is noted. So thermometer, it will denotes the temperature of the container, steel bomb inside. So this is the sample disk, it is provided. So here the coal sample, it is taken, the coal containing sulfur sample are being taken here. The sulfur is burnt with the oxygen and it may produce as the sulfate sulfur dioxide, that is S is converted into, it is a burning of oxygen to form the SO2. So that it is being the reaction, it is carried over here, and this is the oxygen inlet, this is stirrer. So by this setup is called the bomb calorimeter. So from the bomb calorimeter, the calculation it can be represented as the weight of the coal sample is m grams and the weight of the barium sulfate, it is x grams. So sulfur, it is reacted with the oxygen. So this is the combustion, by the combustion method. So sulfur, it is reacted with the oxygen to form the sulfate SO4 2-. Then the whole extraction of the water, it is treated with the barium chloride. So the barium chloride, it is reacted with the sulfate to form the barium sulfate as a precipitate, white precipitate. So the weight of the barium sulfate is 233. So from the 233 grams of the barium sulfate, how much amount of the sulfur? 32 grams of sulfur is present. So therefore x grams of barium sulfate contains 32 into x divided by 233 grams of the sulfur. So next case is m gram. So m gram, it is nothing but m is represented as the weight of coal sample taken. So m grams of coal sample contains here 32 into x divided by 233 grams of sulfur. So this is the calculation. So next 100 grams of the coal sample. So 100 grams of coal sample contains 32 into x divided by 233 into 100 divided by m grams of sulfur. So therefore the percentage of the sulfur is equal to 32 into x divided by 233 into m, where m is the weight of the coal sample taken, where x is the weight of barium sulfate as a precipitate, so into 100. So here we can elaborately we can write down the equation. So percentage of the sulfur present in the coal is equal to 32 into weight of barium sulfate obtained divided by 233 into weight of the coal sample taken into 100. So there we have to find out the percentage of the sulfur by the bomb calorimeter. So here the ash content, that's the next content is ash content. So already we have found out the what is the carbon percentage and hydrogen percentage by combustion apparatus method. Then nitrogen can be analyzed by Geldal method. Then third case is sulfur content. Sulfur it can be analyzed by the, that is bomb calorimeter. Then fourth one is ash content. The ash content is also we are previously analyzed in the proximate analysis method. So where the proximate analysis nothing but we are taken in a crucible, the ash sample it being collected, weight of ash formed. So from that the loss of weight of the produced weight of the ash sample divided by weight of the air dried coal. So we are getting the percentage of the ash content. So here this is the procedure how we have to find out the ash content by proximate analysis. So in that we just remember the what is the procedure of the proximate analysis. So in the proximate analysis is a qualitative analysis. We have find out the moisture content, volatile matter content, and then ash content and fixed carbon content. So after the analysis of moisture content and volatile matter, the same coal sample it is taken in a crucible. So that crucible it is heated without lid at 700 to 50 degrees Celsius, 700 or plus or minus 50 degrees Celsius for half an hour in a muffle furnace we need to heat it. So let us we have calculate the percentage of the ash content, that is equal to weight of ash formed divided by weight of air dried coal into 100. So this is the thing we have to calculate the ash content by proximate analysis. So next one is oxygen content. So finally we have to find out the oxygen content. Oxygen content it does not have a separate method. So from the analysis of the coal sample, carbon, hydrogen, nitrogen and sulfur, we have to find out the ash content. So the total percentage 100 minus total percentage of the carbon, hydrogen, nitrogen, sulfur and ash. So all the samples we have to summate the all the hydrogen, carbon, nitrogen, sulfur and ash we have to summatively collected, and then from that 100 minus percentage of these calculations it represents the it may tells about the percentage of the oxygen. So what, let us see the importance of the ultimate analysis. So in the ultimate analysis importance sulfur and ash content. So first of all first case is sulfur content. So though the sulfur increases the calorific value, it presents the coal is undesirable. So sulfur it is an undesirable one, it should not be present in the fuel. So because it may release the products like sulfur dioxide, sulfur trioxide, that is also causes the corrosion effects on the equipment and it may harmful to the environment also. So that is the combustion products of sulfur, it may produces the sulfur dioxide and sulfur trioxide, it may harmful and the corrosion effects on the equipments. Then the coal containing sulfur is not suitable for the preparation of metallurgical coke and it affects the properties of the metal. So this kind of the coal containing sample it may contains the sulfur amount. So for example the higher the percentage of the presence of sulfur content in the coal, it may affects the products of the metallurgical coke. So and then it may affects the properties of the metal, so it should be avoided. So this is the main significance of the sulfur content. Then next one is oxygen content. So oxygen content, so oxygen is also undesirable one. So lower the percentage of the oxygen, higher the percentage of the calorific value, because whenever we are increasing the percentage of the oxygen, it also enhances the moisture content. So it accumulates the more amount of moisture holding capacity and the calorific value of the fuel is also being reduced. So this is also undesirable. Then finally ash content. Ash content is also it is an undesirable one, because the weight of ash, then we have to disposal the ash, the transportation cost, and then the calorific value of the fuel, everything it can be decreases. The ash content is also it is undesirable one. So these are all about the ultimate analysis of coal. So we are known that what is by coal, and we should know the difference between the coal and the coke. So what is the difference between coal and coke? So coal is nothing but it is derived as such from the earth crust. So we have discussed earlier, that is coal, it is a natural product. So it is from the derived as a natural crust, so it is called a primary fuel. So whereas coke only in the absence of air, and it is heated and it is converted into the lustrous, dense, porous and coherent mass known as the coke. So when coal is heated strongly in the absence of air, it may forms as a coherent mass layer, that porous coherent mass layer, it is called the coke. The process of converting coal is known as carbonization. So the process of coal formation transformed into the coke formation, it is called the carbonization. So let us see the requisites of or characteristics of the good coke. So what are the properties it possesses? So first one is purity, porosity and strength, calorific value, combustibility, reactivity. So these kind of 6 property, it may talks about the what is the characteristics of the good fuel. So first case is purity. So coke should be free from moisture, ash, volatile matter, and then whatever the impurities, it may free from this kind of things. So it should be rich in carbon content, so it may increases the calorific value. So that is the one. So purity, it may represents the rich in carbon content, so exactly. So that's the first case. Then second case is porosity. So porosity, it is also plays an important role. So good coke should have the high porous. If porosity, more air will have intimate contact and combustion will be uniform and complete. So when it is burned inside the carbon content, so the air will be passes and it will be move on, and it may freely, it can be combustible, reactions may occur. So in that porosity, it is much more important. So for the if the porous may be increases, the fuel, it may enhances the value of the calorific value. Then third one is strength. The mechanical strength of the coke should be higher. So for example, in the case of anthracite coal, it is a hard and shiny coal sample. So just like that, here also for any kind of coke, it is a hard, the mechanical strength of the coke plays an important role. So that is the third thing. Then fourth one is calorific value. Calorific value of the coke should be higher. So whenever we are increasing, we are talking about that that fixed carbon content and then calorific value. Fixed carbon, it is increases, surely the calorific values also increases. So when the calorific value increases, it may act as a good fuel. So then combustibility, the coke should be highly combustible, so that's another property. Then reactivity, the reactivity of coke should be less, so it should not react with the other materials, so the reactivity should be very less. So these are all the properties will enhances the characteristics of a good coke. So now we can analyze that what is by coal and coke. So coke is a secondary fuel. That coke is, it is derived from the coal, and these are all the things, so it is better than the coal product. Thank you for viewing.